All right, welcome everyone. I'm Zach Semke with Passive House Accelerator, and it's great to have you all here. I want to just take a moment to say thank you to Walsh Construction for being our Accelerator Partner of the Week. So thanks to Walsh for making our programming possible this week. And before we hand it off to our construction tech co-hosts, we have a exciting announcement. Maybe you saw this come across your inbox, but we are planning and executing a exciting new event next year. And so I wanted to share a little reel about that. Imagine you could learn about 24 of the best buildings solving for climate change, instantly become part of a global movement, and gain the knowledge you need to create real change in what you do every day. Join us for a one-of-a-kind, 24-hour, around-the-world, global online happening, Reimagine Buildings 24. We'll circumnavigate the globe, unveiling a new, innovative building project every hour, complete with actionable solution sets, expert insights, and key lessons learned. We'll connect you with peers from around the world and from your region, so you can build the network you need to create buildings that make a difference. We all know that time is of the essence, that climate change is already here, and that today, too many of our buildings are not only making the problem worse, but also leave us vulnerable to climate extremes that are already here. But that's all changing. A global movement is turning it around, reimagining buildings as resilient and healthy havens, as climate solutions. Tradespeople, builders, architects, engineers, developers, policymakers, and just regular people making it happen on the ground on every continent of our beautiful planet. Join that movement at Reimagine Buildings 24. So I think Michael Ingwe is here to say a couple words about this brand new program.
Yeah, thanks, Zach. And I love that promo reel. So kudos to Alex and everybody else and Kim who helped create it. I'm really excited that we're doing this. I've wanted to do this for quite a while, and it is going to be a lot of fun. I mean, just imagine. Well, first of all, 24 hours is kind of cool, and a project every hour is fun. But also, we're partnering with everybody. We've got the AIA already. We've got Nessie. We've got PHI. We've got Phius. We've got a bunch of affiliates, Passive Ireland. We're starting to get a whole bunch of great speakers. It's just going to be so much fun, and a lot of events that are happening locally. So a couple of specific kind of calls to action. If you know of a group or you're part of a group that you feel like would be a great group to bring in, this is the time to like, hey, listen, my local AIA, they should know more about Passive House. Connect them with us. My local building group, connect them with us. If you ever wanted to have your network know more about Passive House, connect them with this, send out the invite to people. This is really designed to bring, I mean, we all know it. I know it. Everybody else has this group of people that are just outside of our circle. It's huge. That would be great that once they hear about Passive House, they're like, oh, wow, what's that? This is that event, and it's going to be a lot of fun. So call to action is one, register today. And two, invite people, groups, and everyone else. Just connect us with them. It's going to be a lot of fun.
Awesome. Thanks, Michael. So on to the co-hosts.
Thanks, all right. Well, good morning, good afternoon. I'm Sean Sainamore from Vancouver, and accidentally ended up doing an all-nighter, so I'm ready to take on the afternoon, evening, morning shift, whatever it'll be. Because yeah, the bags under my eyes are for lack of sleep, but I've got coffee, and I'm super excited about today's presentation. But just a couple things. We're like 2 minutes away from getting them started. We're like 26 days away from Christmas, and based on that new announcement, RB24, 68 sleeps plus or minus, I think a couple, and adding in the fact that February is a leap year. So get ready for March 7th. It's going to be exciting. And let's turn it over to Kevin, who's going to say a little bit about the people that we're about to have. And I was happy to meet.
Great, Sean. Well, thank you. Welcome to another wonderful Construction Tech Passive House Live. We got a great show with the guys from Akala Built and Miguel from Positive Energy. So I don't want to take any more of their time because I know they're going to share some great technical details. And congratulations on the announcement of the great conference that we'll be having. So over to you, Shannon.
Yeah, super excited for today's presentation. When I saw the project that David and Joe and Miguel were working on, I was super excited to ask them to share it with the community. And yeah, thanks for getting dressed up today, Sean. We're really leaning into the holidays because this is the last construction tech of 2023. So reach out to us, connect with us online, open your chat, turn on your camera, and get ready for a fantastic presentation from David, Joe, and Miguel. I'm going to save their introductions, let them introduce themselves because I want to give them as much of the floor as possible today. So, gentlemen, share your screens. Over to you, and we will collect all the questions in the chat as you go.
Thanks, Shannon. Hey, colleague guys, you want to kick it off?
We do.
Cool.
Yeah, so I'm David Schleicher, Managing Director here at Kala, and with me is Joe Nickels. We also have Miguel with us from Positive Energy, who also collaborated on the project. Before we dive deep into the project, I thought it'd be useful to share a little bit of context about who we are and our approach and kind of what we're working with here in Kansas City and maybe what we're up against here in Kansas City. So for about the past 15 years, we've been really focused on how to build a durable building. Our approach has been to use the Passive House principles once we learned about them back in 2012. And the best way to do it is just do it. Just get out there, put the principles to use, whether you're certifying a Passive House or not, just start doing it. So that's been our approach. Here culturally in Kansas City, there's a very small high performance culture, I would say. When we got into it, there was literally none. The trades didn't know what we were talking about. Architects didn't know what we were talking about. And I should say, Kala got into building as a builder. And I'll tell you a little bit more about where we're at today. But, nobody really knew what high performance was. Banks didn't know how to finance it. Appraisers did not know how to appraise it. So we were up against a lot here in Kansas City. I realize that's not unique necessarily to a lot of markets, but it certainly is here a challenge, and it still is. So to battle that challenge, we built a significant volume of work that's only high performance building. We now have 3 in-house architects that are full-time designing high performance buildings. And we in-housed our framing team this year as well. And they are incentivized upon airtightness. So each member of our team gets a bonus if they hit the airtightness metric on the rough end lower door test. The economics here in Kansas City. Kansas City is pretty well known to professionals outside of Kansas City as having really low building standards. This might shock you, but you can build a 2x4 wall here in Kansas City, Tyvek directly over the studs, and then kind of a smart panel sheeting / finished cladding around the outside, and that will pass code. So it's really low quality. Most of what people value here in terms of what a home might be worth is just size. So size to our market means better quality, which those of us who are in this chat know that's really not the case. Better's better. And everybody knows how to sell the cheap. The real estate agents, the builders, everybody's trying to figure out how to build the cheapest house possible here in Kansas City. So the climate is a tricky one. I just mentioned how full we build. People are used to, in our climate, being very, very uncomfortable in these homes. So we're in climate zone 4A. It's we kind of get the worst of both seasons, the extreme seasons, winter and summer. So it's very cold and dry here in the winter and extremely hot and humid during the summer. We have realized over the last several years, we have more humidity at a higher rate for a longer time. So we have low drying times here in Kansas City. We're just not drying out. Might be worth noting that this week, a week in August of this year was hotter here that week than in Death Valley. So it gets very extreme here, and people are just kind of used to living uncomfortable here. That is, for the most part, the context of what I wanted to kind of set before we dig into the Beacon Hill project. This is the first certified passive house in Missouri. We love it. Our clients love it even more. And we'll share more about that as we dig in.
Yeah, so David mentioned today's project, Beacon Hill Passive House. I guess my name is Joe Nickels. So I've worked with David in a variety of ways over the last 12 years. I've been a project manager. I've done material supply. I've done sales. I've done actual work in the field, installing, commissioning equipment. I've done a bunch of different stuff. And this project I was intimately involved in from the start. This was an infill project in the urban core of Kansas City. You can see Nick, the homeowner, there in this photo. Him and his partner Pooja, they had a keen interest in passive house. They'd done a ton of research. I think that's an important element. They came to us and they were open to it from the start. And so we saw an incredible opportunity to put everything we've been learning for 12 years of trying to use these passive house principles and take it all the way. A few things that stood out to us, if you're talking to your clients, they had concerns about operational energy. They had concerns about indoor air quality. They drive a Tesla. They were ready to invest in durability. They wanted a house that would stand the test of time. They're going to build a family in this house. These were all to us signals that this was a tremendous opportunity. And so we went for it. So that's enough context, 4 or 5 slides. We're going to get into the project. I know this is a tech thing. We're going to do the tech. So here it comes. There's a lot of aspects that we could focus on today. All the passive house principles are important. Insulation, windows, mechanicals. Those could all be their own presentations. And we will touch on mechanicals, obviously, a big part of air. But today we're going to focus on all things air, controlling and managing air. Fundamentally, we build these homes for people because they don't want to live outside. So we want to mark that line very clearly. Where's the air that's inside versus what's outside? Controlling and managing that air gives us a healthy, comfortable, durable environment. All of those things are super important. Probably top of that list, though, is building it airtight. Minimizing loss through air sealing is the name of the game. David mentioned our framing is in-house now. We are incentivizing our framers, our project supervisors, our other carpenters that are involved with the project if we hit our air tightness goal. We're talking about trying to build a culture. That's a way to do it. It has to be an integrated approach. You have to have a strategy. Failing to plan is planning to fail. David's going to walk you through a lot of these assemblies, but kind of the themes that you're going to hear are strategy, collaboration, integration. We did Phius on this project. So the CPHC, the Phius Radar were super critical. Miguel and his team, super critical. It really takes the whole team to make it happen. We had some unique challenges. We had a wide variety of assemblies. I'm going to hand it back to David. He's going to kind of walk you through those and talk about their integration as well.
So we're going to focus on the just how we got to the airtight layer before we dig into the mechanical setup. In Kansas City, we kind of rule of thumb for our values. It's a kind of 20, 40, 80 to get as close to passive house certification. So R20 below the slab, R40 in the framed wall, R80 up in the attic ceiling. This is the basement condition here. It's half conditioned, half garage. So what you're seeing in these photos is the conditioned space. 15 mil plastic has been our go-to, sealed at the seams, all the penetration, sealed at the foundation wall. Foundation wall then becomes the air barrier. We do use about 4 inches of VPS over the gravel before the air barrier. Then we put our 4 inches of foam on the foundation wall. It's looking a little blurry, but what I'm showing now is the garage ceiling. We moved to Intello for our air barrier separating the finished space above as our air barrier. You can see it down in the bottom left in the section drawing there, where the air barrier transitions down below the slab and then up, separating the garage from the condition space. We did use SIP panels for this project. It's a hybrid wall for us. It's a 6.5 inch SIP panel. Most of you are familiar with what a SIP is. Those are not. It's basically two sheets of OSB with a sandwiching a foam core. So that's our primary air barrier, is the outside layer of the SIP wall. Primary driver for using the SIPs was cost. Some cost savings for this particular project, as well as some of the collaboration we got with the SIP manufacturer. So the SIP manufacturer also provided a lot of the trusses and the full package. So when it came into integrating the mechanical delivery, we had some details that we could work through for planning that we normally don't get through the architecture team. So here's our 2x4 wall on the inside. So the SIP panel, you can see that's the OSB beyond the SIP panel. Beyond the 2x4 wall. This helped us get to that target R40. I believe we're at R38 for this walls when it got fully modeled. For our local trade, this is something they're used to working with. You know, running electrical and plumbing through a 2x4 wall is pretty standard for them. Running it through a SIPs would not be. Down the bottom left, you can see the air barrier moving up the outside of the SIP and then transitioning on the underside of our roof truss. You can't see the roof truss unless you reference the drawing on the left, but our air barrier is on the underside of the roof truss. We sheet the underside of the trusses. That's our air barrier. Collaborating with the truss manufacturer and the entire team gave us the ability to put in basically a plenum for a lot of our ductwork on the second floor. So that's where that offset is when it jumps up there. We keep all of our ductwork in the conditioned space this way. And this is you know, an image of all those air barrier connections kind of coming together in a continuous way, below the slab, up the wall, underneath. So that's how we got to our air tightness metric. This is our results of where we landed on this particular project, which got us to about an ACH of 0.3. All right, now we're going to dig right into the mechanicals. So in Kansas City, you certainly do not have to submit any mechanical drawings or any modeling to any jurisdiction for mechanical. So it's definitely challenging. So
They don't really inspect it either.
and they don't inspect it, and there's nobody doing manual J's or any other manuals. So our strategy for this project and projects that we're on, we try to get into the mechanicals very early. Most architects treat the mechanical room, in our opinion, like the last kid getting picked for kickball, when he probably should be the team captain. So we try to get everybody in the room at the same time as possible. We knew we were going to be collaborating with Miguel and Positive Energy, so they were certainly part of this discussion. The architect, the SIP provider, our HVAC contractor. Who am I missing? CPHCs, everybody was in the room together. The framer. We got everybody in the room. So got everybody in the room. And then collaborating with Miguel, we started to understand what components that we might actually have in this thing. So these are just free floating components that need to find a home. They need to find a way to connect to each other. And but we had a good understanding of all the components. So ERV, makeup air, dehumidifier, air handler. And then this is pretty awesome for us. This is really where Miguel and his team really started to shine for us, because this image here is not something we're used to on any of our projects. Is a mechanical layout the start of mechanical and how all these things connect. So, you know, this was the first time we were integrating dehumidification with an air handler. So it gave us insight of how these things actually connect, as well as our makeup air connecting with our ERV intake. So we began to be able to visualize all these things, which is super helpful for everybody that's collaborating on the project. And then this is just a quick snapshot of parts of the mechanical room. So starting on the left, we have our ERV. The next image is our makeup air. So the big box is our filter. As it makes the U at the bottom, it goes through the fan and then our silencer. Everybody's familiar with the water heater, heat pump water heater, our sump pit and radon extractions down below. And then off to the right is the side of our return into our air handler. So I'm going to hand it over to Miguel. It was super awesome being able to work with a team like this, and it brings so much clarity to the project, and we learned a ton. So it's yours.
All right, thanks. It's so great to see all these photos come together. It's always exciting to work with a team that that cares, for one, and particularly when you have an owner who's very interested and invested. It's pretty exciting. And I remember, I was just like, as you were describing, Nick, I remember coming away from our initial phone call, and y'all grilled me with so many questions for so long, and I was like, damn, they're serious about this. So I was very happy to be selected. Felt good. But I'll tell you guys a little bit more about Positive Energy. You can go to the next slide. We're a mechanical engineering, or I would say an MEP engineering, mechanical, electrical, plumbing engineering company based in Austin. But we have staff members all over the country. We do work all over the country as well. And we're a little unique in that we focus exclusively on residential projects. We sort of operate at that really interesting nexus between very high-end custom homes, as you can kind of see here, some of these projects. And then if you click the next slide, we also traffic and passive house. And the house we're talking about today is the first image there featured. So it's a really special and lucky place to be as a company. We get to really live our values and practice, craft, I would say, in a way that many MEP companies don't get to do. And it's sort of a crazy business model to build, but we did it, and we're loving it, and we're stoked to work on projects just like this. So let's dive into a little bit of the systems here. This is cool, right? Like, everybody's like, oh, 3D, this is amazing. Let's talk about all these different components. And I want to back it up a little bit, because I think there are two types of people when you come to the table thinking about mechanical systems. They want to know, like, maybe it's an architect who's very, very interested in the aesthetic finishes, and so they want to start the conversation talking about the registers. They want to talk about diffusers. They want to talk about how that integrates architecturally. And then there are the nerds, who many of you on the call are probably in that category, where you're like, tell me about the systems you used. And you want to get into the technical specifications that we did, the strategy that we went through. And like, that's great. Both of those are very valid discussions to have, but none of it can happen, right? Like, we can't get to this without, next slide, a whole bunch of math. So anytime you are thinking about a mechanical system, you have to start with understanding what the loads are. And you have to also map that thinking over to, like, as you're developing an understanding of the heat flows through the building, the indoor air quality criteria, you need to map that over to what the owner's expectations are, and to what the market that you're working in, what the local trades actually know how to install. And I say that because that's actually so much more important than any, we could design a system that would just be world-class, like best in class technology, and it could be as sophisticated as we want, but that doesn't matter if the people who are doing the work don't know how to actually put it together. And so we really try to thread that needle, right, where we're taking client criteria, we're taking local market dynamics, and we're taking what we understand as well-vetted pieces of equipment, into the design. And it all comes from, what are the actual heat flows. So a big part of this can be Phius certification, right? And when we think about criteria, that's a really important thing for us to map onto. And if you go to the next slide, you can see, like, when we establish a basis of design.
Frozen.
All good, don't worry about it. When we establish a basis of design, we're quantifying those various components or considerations that I was just mentioning. Client criteria, what is the climate zone we're working in? What are the actual demands of the home? Oh, got it back, I see. Wow, well done. And we lay all of this out in our design set. So it's very well understood as we go through our design process. What did we say we were going to do? What are the commitments we got from the architect, from the builder, about the reliability of the wall assemblies? And that's what really makes the magic happen on passive house projects. We know for a fact that those walls are going to be just bomber reliable and super resilient. And then for Phius, if you go to the next slide, you can see we've got to be in step with the heating and cooling targets. We've got to make sure that we're communicating with the CPHC, that the EUI target for the project is within range for the systems that we design. And we don't design systems even for non-passive houses that wouldn't actually qualify for passive house certification. So there's no real difference in our approach when we're looking at a building to building in terms of the fundamental system components. So that's definitely part of our ethos as a company, is like, even if they're not going for passive house, we're going to try and get them as much of the way there as we can within our sphere of influence. And we're going to be pretty noisy about stuff that may not be in our sphere of influence too. But that's another presentation for another time. Some interesting components in this house. We actually did need to do a makeup air system. Anytime you've got a range hood that's pulling more than 400 CFM in any kind of house, you need makeup air. For passive houses, the pressure differentials can be pretty significant. And so there's some massaging to be done about whether or not makeup air systems make sense. And when you're in a cold climate, whether or not you need to preheat that, what are the energy costs of that, et cetera, et cetera. And with any time you're doing a passive house, you need to be really careful about exterior penetrations. And so for this one in particular, we put in a normally closed, I think it was, so like powered open makeup air damper on this. And we had to, I think I was looking through some of the correspondence kind of late in the project with the mechanical contractor and the folks at Kala, and we were dialing in the time it took for that to open and close, just to make sure that we're preserving that airtight barrier as much as we possibly can. Let's see, next slide. So there were just some like fantastic shots we were able to pull out in isometric view for this project. And we had such a wonderful time collaborating with Kala and the mechanical contractor on components that they weren't sure about, or that they wanted to maybe swap for something they could get locally. Just dialing in questions. Really, more than any of these calculations, the flow of communication is a technology that should be leveraged, I think, in ways that it normally doesn't get to be leveraged, especially on residential projects. So that's really one of the big powers I think that design has when you're doing a mechanical design. It's the ability for someone who's sitting with the math to be in open dialogue with somebody who's actually implementing the systems, and having a really sophisticated understanding of how to make sure that the coordination pieces are occurring as well. If you go to the next slide, you'll see what I mean. Feel free to take your phone out, scan that QR code. You can actually open up the Revit model in an Autodesk viewer. We've started printing this on our plan sets. We've found it has been a tremendous help for contractors when, back in that isometric view, there may still be ambiguity, even with a really well-designed, really well-labeled system. What this does is it just adds one more layer to reduce that ambiguity. And I think that's really, really important. But if you want to understand the system types here, we went with Mitsubishi heat pumps, right? I think we did a P series and an M series on this. P series is a hyperheat unit. We did the Zender ERV. We did what was at the time called an Ultra Air and is now called Santa Fe 70H dehumidifier. The makeup air system is a Fantech system. What am I leaving out, guys? I think it's metal ductwork with the only times we really like to use flex duct are the last few feet of a runout to avoid vibration noise transference from a unit to a register. And yeah, I don't want to take up too much more time because I know there's plenty else to talk about, and we can get into Q&A later on.
Yeah, thanks, Miguel. I think, David touched on this earlier. Our trades in KC don't necessarily know what we're trying to do. They kind of trust us, and we sort of take their hand, and being able to partner with Miguel and Positive Energy just changed that whole equation. I think there's a few ways. Like, one is just having a plan, having something to reference to make sure everybody's on the same page. It just puts everyone in a position to succeed. It helped with the initial bid phase. We were able to bring that information into quote, do some value engineering, work with Miguel, work with the homeowner, work with the whole team on that. But I think probably the most important was by starting early, we built this really powerful foundation of trust. And every project has issues. Like, it's not like, oh, we did this and then we went out and built and it went perfectly and everything was amazing. Like, we still had problems, but those problems were smaller. And we had this foundation of trust and collaboration. And so smoothing those problems out was just a totally different thing because everybody was bought into the same idea and the same commitment. So it's just hard to overemphasize that, I think.
Absolutely.
So I'm going to go through a few more slides, just kind of highlight some of the execution components. David highlighted some execution on kind of the envelope piece, controlling in versus out. Miguel's really laid out the mechanical piece, and this is just going to be kind of photo time a little bit after this slide. Leakage, I'm not going to repeat what Miguel said, like do a manual J, do a manual S, like engage someone, do it right. And then we got in there, we did air seal the ductwork. We also used aero barrier on this project for the envelope. We have found, aero barrier, aero seal to be really effective at hitting these targets. And we found it to be even more effective if you have a good plan and you have a good starting point. It's really easy to make it super tight. Not this project, but there's another project we did kind of experimentally. We got the envelope down to like 0.00 effectively by using aero barrier. Not saying that's like necessary, but my point is that like this technology works and you do have tools to achieve some of these metrics if you just put yourself in a good position to start with. So the ERV, we used a dedicated ductwork standalone system. Miguel touched on a little bit. This is all flex duct. I mean, we like this. We felt really emboldened by talking to Positive Energy. It makes filtration better. It makes your both of your energy exchanges more efficient for humidity and for temperature. It allows us to target extract. So we're pulling air out of bathrooms, pulling air out of the laundry room, pulling air out of the areas where it's spent or smelly or just not what you want. And then we're targeting our supply as well. We're bringing it back into bedrooms, bringing it back into living areas. And you just can't do that with a system that's tied in return side. Maybe you can do it with the extracts, but you don't get that control. If we're moving more than, just one more note on the ERV. If we're moving more than 1200 CFM with like a forced air system, this thing's moving 180, 200 CFM continuously. It's really the respiration system. And everything is optimized to that from design all the way through commissioning. We have a system that does something different than the heating and cooling system. I think that's really important. That's also me commissioning it, so I'm biased. Makeup air, Miguel touched on this a little bit. On the left, you see the extract out of the home. There's our exterior vent. And then this same system that David and Miguel both kind of walked you through, where we've got that damper. You can actually see the control on the wall on the far right. Turns that damper on, brings it down. We're able to filter that air, silence it, just minimizing the penetration and going through that design wouldn't have been possible without the collaboration. And then dehumidification. This is a really big deal too. We find in our climate that we have so many different conditions. As we start to super insulate these walls, we actually lose some drying impact to the inside because we're so well insulated and so solid. So we put a dehumidifier on both of the air handling systems. It just makes a huge difference for us in our market. It's typically about $4,500 to add one of these. And it's just so worth it for the durability that you get out of it. We just put it in every estimate from the start. And that allows them to control comfort all the way through the year. Next slide.
Sure what's happening here. There we go.
Hey, we got it. So cable dampers, this is kind of the last little feature that we wanted to highlight. These cable dampers allow us to balance airflow through the face of the diffuser on our heating and cooling system. So this gives us a much more granular method of airflow control, which is really important for commissioning. We've got this great design. We want to nail it. But it also does, I think there's a human impact here. Like, we build these homes for humans and we want those humans to be comfortable. We can actually adapt these to the unique needs of the occupants. So these are like room level dampers. If, you know, you've got a guest room that maybe doesn't need a lot of air much of the time, but then grandma comes over for Christmas and she's staying in that room, you want to be able to give her what she needs to be comfortable in your home. I think that's really important. It's hard to like, you know, it's hard to put a number on what that's worth. But these cable dampers do give you like long-term management capability of the home, as well as that really granular commissioning detail that you get up front. So these are just like a few strategies that we pulled out to kind of highlight this tech talk. I'm gonna hand it back to David, kind of put a bow on things, and look forward to any questions you all might have.
Yeah, so the results, there are several positive results that came out of this project. I'm just going to hit on a few. Joe already kind of hit about the human aspect. This is one of the homeowners, Pooja. You know, we're building these homes for humans. That's something that can't be lost in all this tech talk. It's all about who's actually going to be in these homes and what they're experiencing. We've had several clients after we built their house. The first thing they talk about is the comfort. And it's really interesting as they go on trips and stay in other buildings after they've been conditioned. They're either spoiled or they're having trouble adapting to a hotel room. They start to miss their home, which is really great. And it certainly makes us feel awesome to get this kind of feedback. It's very rewarding as a builder to get this and to hear it and know that people are actually loving their home. We also got a beautiful house. Our belief is that design is the #1 rule in sustainability. If it's ugly, nobody's going to want to take care of that house and it will likely fall apart. So beauty is important. This thing is amazing. It lives amazing. It was a great team effort where it kind of combines functionality and engineering and beauty all into one to deliver this spectacular house. We're super proud of it. The clients absolutely love it, which I already mentioned. But the last thing is we're starting to build a culture here in Kansas City on high performance, using the passive house principles. And you know, when I got started in this, it was just me and a few other guys. Fast forwarding today, we have a thriving business. We have 3 projects right now that are going through design certification with Phius, and about 9 to 10 others that are high performance that are not going for passive house, but all of high performance. We've been able to develop a team of people that are super committed to it. And yeah, the shift in the local culture here in Kansas City is starting. We're super excited to be a part of it, and that's it. We're here to take on any questions and let you guys take it from here.
I'm stoked for questions.
Don, you want to kick us off with a big thank you to these guys while I collect the first couple questions that we're going to address in the chat?
Yeah, absolutely. I love this presentation because we're now kind of getting into the weeds, especially in my market where we're looking at mechanical rooms and trying to define it. When if you guys know Monty Paulson, if you've ever taken his pattern language course, the first thing he talks about is you design your projects looking in the mechanical room. And so
The stuff that Positive Energy is doing is spectacular, to the point where I think I'm going to put a presentation together that just highlights really good mechanical rooms. So if you have a mechanical room that you love and you're proud of, send me the photos and send me some details, because I want to start collecting mechanical rooms and really dive into some of these systems. So Miguel, me and you, we're going to definitely have virtual coffee and have more of these conversations. So was that a good segue? Shannon, you ready to fire up questions?
Absolutely. And I want in on that coffee, that virtual coffee. And yes, let's create a coffee table book with just mechanical rooms. I would buy that.
Thinking about
There's
making
that segue. Okay. So
Be a mechanical room book?
that's what we're talking about.
Nobody would return it.
Oh, that's the best pun ever. Miguel and Tala, thank you. That was a fantastic presentation. I threw my own questions into the chat, but the first one we have up is from Carlos. Carlos, it looks like you're here. Would you like to unmute, turn on your camera, and ask your question yourself? If not, I can always ask it for you. It was really easy. It was, who is your SIP manufacturer? Who did you guys use?
We used a manufacturer called EPS out of Ranger, Iowa. They're just north of Des Moines.
I've checked them out before. Thank you. And you know what? It looks like, because we had such a fantastic presentation, that we will take a quick break and thank our wonderful sponsors for making this possible, and then come back with more questions. So everybody sit tight.
Great. Thanks, Shannon. I just want to give a thank you to all the organizations that make our work at Passive House Accelerator possible, starting with our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thanks to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Partel, Rockwell North America, Stocorp, and Zola Windows. Thanks to our champion sponsors, Bewizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, Proseco, and Source 2050. And a big thank you to our patron sponsors as well, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Longboard, Owens Corning, RDH Building Science, and Sanderson Sustainable Design. Thanks, sponsors. I think you're muted.
Thank you, Zach. Yeah, I thought I was unmuted. Our next question up is, well, it's one of mine. I was asking early on when you were showing just the construction, the air barrier at the ceiling plane. It looked like you used that sheet good up there. How did you find the install of that? And would you use that method again?
Yeah, we've used that method quite a few times. So kind of how we implement it in the field is we get the exterior wall stood up the second floor, and then we take a 12-inch flange piece, so a 12-inch piece of OSB, and we set that on top of the wall, making an air seal connection to the outside layer of the sit panel, that OSB, and then you're going to have seams usually every 8 feet, so we seal that from the top, and then we drop our trusses on top of that, and then we come back and air seal the underside of the truss with more OSB, tape all the seams, and then eventually frame our interior walls below that. Well, prior to the interior walls, we fur down the ceiling 1.5 inches and use shallow depth LED lights that can recess in that 1.5 inch cavity. And then we frame our 2x4 interior partition walls. And yes, we will likely continue to do this. A lot of our current projects that have a vented attic do use this. We find it very easy to air seal. We find it able to hold a lot of weight of the insulation. So we're usually dumping around 2 feet of insulation, which can get really heavy. So it's a really durable product for us to use. but we're open to other ideas on for different conditions, but it's been our go-to for a while.
Okay, I made a mistake then. So it's not an Intello with secured to the bottom of the truss cords. It's OSB.
So yes, but we did use the Intello separating the garage, which is on the lower level. And it does have finished space up above. So we've gotten away from using sheathing on that area because it doesn't have as much drying potential, because you basically have you have a subfloor and then you have sheathing down below, and it doesn't give you much drying potential over time. So we migrated to the vapor open Intello product for that.
Yeah, because you've got the unconditioned garage below. That's really interesting.
You got it.
How did you handle the systems in that area?
Say that one more time, Shannon.
How did you handle running the systems in that area? Did you keep them out of that floor plate completely?
We came up through the basement with the systems. There was lots of room there to move up. I don't think we ran into any significant like penetration issues through any of the air barrier, except for the exhaust points for things like the ER and intake ports for ERV and for the makeup air system. But you flash those well and make sure that you have good dampers, and you'll be in pretty good shape.
Awesome.
We're still insulating in that cavity too. I mean, we're filling that whole truss, so it is still accessible for mechanicals. We just try to hold them as high as we can.
Yeah, I'm dealing with a similar situation on other projects, so that's where the curiosity is coming from. Thank you very much for indulging me. Our next question up is from Tim Sweeney. Tim, would you like to unmute?
What you got, Tim?
If not, Tim, I can ask your question for you. It says, for the Cala project, if you have freezing conditions in the winter, don't you also want a smart air barrier between the SIP wall and the service cavity to stop interior moisture from migrating outward and freezing when it gets to that outside barrier?
You're talking about a vapor barrier?
Yes.
Okay. Kyle, what are y'all's
air barrier? Yeah.
Yeah, so we got vapor drive happening both directions throughout the seasons. It's driving in during the summertime and it wants to drive out during the winter. So we do our best to have vapor open assembly. The sheathing layer on the outside of the OSB is going to be outdoor temp nearly all the time. There's no air leakage getting to it. We're also sealing the inside seams of the SIP panel. That's part of the process. So very little air leakage that's actually occurring through that assembly. And then, like Joe mentioned, we kind of backstopped everything with the aero barrier, really driving that air tightness even down further. Just got a belt and suspenders type strategy there.
Yeah, what we found from working with our CPHC is Ryan Abendroth with for what's the name of his new? It's
Build Zero Consulting.
Yeah, thank you. Just blanked on that. So that's one of the great things about working with him is his modeling is they're doing the hydrothermal analysis, because we had that concern too. And this project with SIPs we've built with 13 different kinds of wall assemblies over the last 12 years. I mean, if we have any doubt, we model it to make sure that it's going to perform the way we need it to. We get it as airtight as we possibly can. And then having that dehumidification piece is just such a great investment for our climate, because we can always create a delta. If we get saturated where we're high humidity inside, high humidity outside, we can't exchange that out. We're not running our AC enough to dehumidify. So having that standalone dehumidifier really, we feel is a pretty risk-free assembly when we can't stay vapor open.
Yeah, and I think, of course, everybody should model this and really understand what they're doing before they make a decision. But I think you'll find more often than not in most of the climate zones across the US that a vapor barrier is not a crucial piece of your assembly if you're providing for dedicated dehumidification on the interior. It's perfectly valid to dry to the inside, just like people have conventionally dried to the outside. And really, you're better off spending more time focusing on air sealing, because that's where the overwhelming majority, almost 99% of your moisture transportation is going to occur across the assembly is going to be through the air. So the amount of moisture that's diffusing through materials in vapor form is pretty minimal. And if you have systems dedicated to dry it out, you're going to be fine. And then of course you need an assembly that if you have enough moisture moving through the walls that you're getting enough bulk water to get the freeze thaw issues that you're kind of pointing out, you might have other issues beyond just the air sealing and vapor components. It sounds like you might have some bulk water issues to deal with.
Excellent point. Yeah, once you control the air, you can control everything else. But if you don't control the air, the water's coming in, the vapor's coming in, and that dehumidifier is going to be working overtime. Okay, our next question up is, I'm going to give it to Sean St. Amour because I can save mine.
Perfect, no worries. I just had a quick question, which I believe was answered. I was just wondering what the hot water tank system was, and somebody put in that it was the A.O. Smith heat pump hot water. And just wondering if you had to duct that outside, or was it just getting air from the mechanical room?
Yeah, it's just getting air from the mechanical room. It's not ducted in any way. We usually are placing these in the mechanical room. We're constantly trying to think of other ways to use that system to extract heat. It's very helpful during the summertime. It definitely cools the space, takes some of that unwanted heat, puts it into the water. But it has an adverse effect during the wintertime when we're trying to heat the space. So any heat producing elements that might be always on, like any data, not a modem, but any like router system that might be cable boxes, anything that has heat that's coming off nonstop, putting in there. There is desire to do solar on this house. It's a great candidate for solar. So battery storage, there's room in this mechanical room, and those put off heat. So use that heat as well as help keep everything cool in the room that needs to stay cool so it can perform for the long haul.
Awesome, great stuff. Thanks.
All right, next question up is Jim Madison from Madison Millworks.
Hi, David and Joe. Thanks for the presentation. You mentioned this is your first passive house project, which is 12 years out from your initial research. So what advice would you give to yourself 12 years ago, or to a small business with the knowledge you have today? And how do you stay authentic to your values over time?
Yeah, I could go on and on about this particular question. From a mechanical perspective, what we learned, we were early adopters. One of my house, we retrofitted. It's a mid-century modern house built in the 50s. It had a 5-ton AC and forced air furnace. We got it down to 1.5 tons. It's still about a 0.5 ton oversized because we didn't know how airtight we're going to get it. We did use a mini split heat pump system. We had a couple inverters inside. Our first few homes that we built like this, we were using hidden cassettes, not the wall hung units. We were trying to hide them so they were pleasant. We got away from those. So we've gone back to a system very similar to what is in the Beacon Hill house, is a fully ducted air handler. So a lot of the early adopters of passive house seem to use some of those inverters. In our experience for single family homes where you got multiple rooms, we've been using air handlers fully ducted. What else? So kind of staying true to the values, we kind of drew a line in the sand a while back. If a client calls us up or a potential customer calls us up and is interested in working with us, we make it very clear from the very beginning, we're not like anybody else. Your walls are going to be 3 to 4 times fatter than a normal wall. We just cut it right there. It took a long while to get there. We had to build projects. We had to experiment. We had to do a lot of things we would never do again to kind of get to this point, but customers love it. People love living in these homes. We've built a portfolio of past projects and in a healthy pipeline of projects that are in design and coming down the pipe that enable us to do that. But there's certainly tons of learning lessons along the way. Joe probably has something on the tip of his tongue that he would like to share as well.
Joe always has an opinion, is just something about Joe. I think I would say one of the biggest things, like when we started, there was a period of time the business was just David and I, like literally just doing whatever we had to do to make ends meet while we were like getting trained up, like doing windows, cleaning leaves, like just doing whatever, because that's just what it took to get to that point. And I think where we really found success was when we stopped watering down like anything that we were doing, when we gave the product the credit that it's worth, and we gave ourselves and our training the credit that it was worth. And we realized that like if people are educated and they understand the difference, like that has value. It might not always be enormous monetary value. Like I'm thinking of one client, we did a small remodel for their family, basically like a living room and a little bit of a kitchen. And like 6 years later, they built a near passive house, because over the course of that remodel, we're just like constantly educating them. David touched on, there was no culture. So we just had to like kind of build that culture kind of one person at a time. Like we ordered windows from every region of Europe. We set up a separate company to just be able to bring stuff in. Like we got licensed in selling and commissioning different equipment just so that we could offer it in our market, because it was only on the coast. Like, anytime there's like, David's like really inspirational on this, like every obstacle is an opportunity. So if there's something that's like not working, don't sell yourself short, don't sell the product short, don't sell the homeowner short, like find a way to push it forward. And it might take 12 years to build a passive house, but we've been using passive house principles really consistently for probably 7 or 8 years, on literally every project. So I think that would be like my one thing, is just like you're selling yourself short, you're selling the product short if you're not willing to like build the value. Even if you can't do it, even if you can't execute it on a project, like how would you execute it? How would like communicate it to the homeowner, give them the option? You just that would be my thing.
Well said. I kind of fall into the Michael Ingwe school too. Like when in doubt, just don't tell them it's passive house. And
yeah, that's where we are now.
Just build it.
Yep, just build it.
Yeah, that's a perfect place to take a pause and really appreciate how hard it is to overcome obstacles, let alone to see them all as opportunities. And a whole nother coffee conversation, and maybe another coffee table book, is windows. Talking about windows and sourcing some of the stuff that is really difficult to get. So we are about to hit the top of the hour. I think we're hitting it right now. So first, I want to thank everyone for coming. We really appreciate that you took some time out of your busy work day or the end of your work day, depending upon where you're zooming in from. And if you have to go, put the kids to bed, make dinner, get back to work, we understand. But if you can stay, we've got a bunch more questions. So Kala, Positive Energy, can you guys hang out for a little bit longer, or?
Sure.
Yeah, let's do it.
Sean, are you still with us? Do you want to bring
Yeah,
us home?
I was just taking a screenshot of all those amazing people, and Kim, I'll definitely get Passos Canada to connect with you guys to make sure they're on it. So here we are, we're at the top of the hour. Some of you may need to leave to carry on. Appreciate you all coming out. Hopefully you will join in on all the fun festivities that are going to go on in December. Definitely December is a planning month for 2024, so make sure you put on your calendars March 7th to 8th and get enough sleep before it happens, because 24 hours, there'll be a few people like myself that will be doing the full 24 hours. So any coffee brands we would need fundraisers support, get them on board, because it's going to be 24 hours of festive fun. So Shannon, what do we got left in questions?
We've got a
Good
bunch.
question, Sean.
Throw them in.
How do you not sleep and seem so energetic? I need the secret.
Because that coffee I had at the beginning just kicked in. So whammo.
It's hard to hit a moving target, Miguel, and I think that's Sean's philosophy in life. I try to follow it myself. Our next question up is from Stefan. Stefan, would you like to unmute and ask your question?
Yeah, why not? Why not? Thank you very much for the lovely presentation of a really, really nice building. And it goes always very interesting to see how well represented the M&E was. I think that solves probably a lot of problems on site. And I'm particularly interested in your duct system, because duct systems are, when you use them as excessively as you do, they're mostly a cost factor. And I think the flexible pipe system looks probably quite reasonable. And I was wondering what you expect these pipe systems to last. I mean, the building looks very, very nice. This will stay for a long, long time. What does a ventilation system offer as a lifespan?
So those are the Comfo tube ducts that Zender actually manufactures. I can't remember if they're UL listed or not, in meaning, ready for stateside, like kind of rating and mass distribution, but we've got them installed here at our office as well. They're super sturdy. At least the older generation that we have, I believe they've updated their product over the last couple of years, but it's essentially like a plastic tube with an insulative sort of wrap around it. It's not really thick, but it's enough. So it's not actually like super slinky flex duct like the stuff that you might get at the supply house. It's got some it is plastic. I'm not sure what kind of plastic it is, but I don't anticipate it having any serious issues for the lifetime of the building. It should last just as long as anything else. The ductwork that we used for the HVAC, or for the heating and cooling and humidity control components, is we default to metal. We prefer round. Generally speaking, it's usually more optimal or cost optimal for residential projects. But you can do rectangular as well. But those snap lock pieces are pretty economical for residential projects. And then when we do any flex duct, like actual flex duct on systems, it's usually the last few feet of a run out, and it needs to be pulled completely tight and actually installed per manufacturer specifications. And that's really a sound attenuation play. It's not really for performance, although we don't, we have enough juice in the system that we're not seeing any significant drops or anything just by having that at the last few feet of a run out. Does that answer your question?
Very much, yeah. I was quite intrigued. Thank you very much.
Yeah, I'm happy to talk about ductwork anytime. Just call me.
Miguel, can I piggyback on that as well? I see that you have a dehumidifier for each system. How do you control and run the dehumidifier?
We're big proponents of having system redundancy. Like the heating and cooling system should be able to heat and cool. The dehumidification system should be able to handle humidity, and the ventilation system should run. We design for continuous ventilation during occupation. So we're not really trying to interlock these things in a way that they're dependent on one another's sensors. So a dehumidifier is really only responding to relative humidity in the space, and you can give it a set point for whatever your target comfort is in that 40 to 60% relative humidity range that is recommended in public health literature. So it's really only going to turn on when the space conditions get humid enough to warrant it. And during the summer months, you're going to get most of your latent control from the actual cooling unit. So it's not it's really the shoulders, and same in winter, right? Your heater, even heat pumps are going to dry out the air quite a lot. So in those shoulder seasons, like April or October, when you don't have a lot of sensible load, but you do still have quite a bit of latent load, the dehumidifiers can jump in and compensate.
Cool, thank you.
Great question.
Yeah, and piggybacking again, how early was the mechanical installer brought in on the project into those design discussions? You said they were great to bounce ideas off of and talk about layouts with. Is that internal to Cala? Is that someone that you guys brought in just for this project and was new? And had they installed Zender before and seen this kind of system before?
So yes, to all that. So prior to getting our contractor on board on our projects that were performance, Cala was installing their own ERVs and their own inverters and heat pumps, and then having our contractor actually charge the system with refrigerant. So we've migrated away from that. Our mechanical contractor is on board for what we're doing, but they need to be on board early. So they did come on board really early. You know, some of our early pricing exercises for systems that we're used to putting in were a bit more modest than what we ended up doing for this house. So there was plenty of learning that needed to happen for everybody on board, but they were on from the very beginning. You know, getting the second floor conditioned was a concern. Some early architectural layouts didn't have much room for getting ductwork or a second system up there. So we basically converted a second floor closet into a small mechanical room. It was in one of the photos. Was the impetus of doing the plenum truss, you know, in our roof truss. So we got them on board and collaborated. It's never perfect, but you know, you got to try.
Great answer. Next.
So before you dive in, I actually misspoke about the Comfo tube ductwork. So I just want to correct that really quick. Hat from my team reminded me that the Comfo Flex, which is the product that we used here, is a type of flex duct. It is not the plastic hard tubes or hard plastic tubes. It's actually a flexible product that is UL listed. The Comfo tube is not UL listed, which is why we went with the flex here. But it's, again, it's not the same kind of flex duct that you see, you know, that you could like chop in half with a Pop-Tart. It's pretty beefy, like proprietary fabric that they make. And
it's densely woven and it's wrapped around like a wire kind of spiral. So we've used both of those. The plastic stuff there's some challenges. I would definitely recommend using the Comfo Flex in any situation possible. The Comfo tube comes in huge rolls on pallets. It's hard to work. It's super rigid. It can be difficult to turn corners, like not just turn corners in like a healthy sweep, just like turn corners at all.
Yep.
And the Flex stuff, it's easy to extend. I think a superior product, and it's UL listed. So
which is a big deal sometimes, right?
Yep.
It is, and it's worth noting for that previous question regarding durability on the ductwork. Both of those ERV tubes are durable enough to be pulling through walls during construction. So that's going to be their biggest test on durability. Are they going to get snagged? Are they going to rip? Are they going to? Both of them are great to work with and hold up during installation.
Just watch out for the little fletch plates on trusses. Like those are, watch out for those.
Good advice. Amazing. All right, next question up is
Thanks
Jesse.
for clarifying it.
Yeah, sorry about that.
Jesse, would you like to unmute and ask your question?
Sure. What's up, party people? I was asking about cable dampers. Did you have pushback there? I think that's typically more of a commercial application, but is a great solution for multi-story installs and things like that.
Did you guys get pushback?
We actually pushed back at first, if I remember right.
Yeah.
I think it's okay to say, right? Like, I mean,
Try to balance
they
budget.
came through and were like, hey, these are really expensive, and like, what are they and why? And you know, we just need to be educated on that. And same thing with the homeowner. But I think Miguel, I don't know, maybe you don't remember, but I feel like we were kind of skeptical at first till we
Yeah,
understood.
I do remember, and I think it's totally valid. Like, cost is a serious concern, even on a really nice home. You know, you've got to figure out how to balance things out, and this strategy, I think, is a cool one, and it's probably not the right fit for every project. If you're looking to trim up the budget, cable dampers are definitely one of those things that you can achieve another way. But any of you who've tried to test and balance a system, like, that is hard work. It's more art than anything. And the cable dampers can really simplify the process a lot. You're not like in different rooms with walkie-talkies or on your cell phones, trying to measure and adjust things on the fly. And it does give you, I think, a lot of precision and control. So, if it's an option for you, then you should pursue it. But if you do get a lot of pushback, it's expect it, and it's totally fine if it's not the winning strategy.
Well, I'm going to read up, because as soon as I found out during the dry run that that's what you guys were using, I'm all ears on that one. All right, our next question is from Carlos again. Carlos, are you still here? Looks like you are. And if you don't want to ask your question, I can ask it for you. What was the approximate square footage cost? Now, that's a Harvey question, but Harvey's not here to ask it, so we'll take it from you, Carlos. And you can always say it depends, because maybe you don't have that information yet.
Yeah, I'm trying to remember. It was around 300 a square foot in the end. I think we were a little closer to 320. There's too many projects, but I know that I'm not a million miles off.
That's a good price point for that beautiful house.
I don't remember what the mechanical specific budget was for this, what the bid wound up being, but we've been seeing pretty consistently these days around, for a system type like this one, around 30 a square foot. And depending on how complex or the specific market dynamics may drive it up. Like when we do stuff in California, apparently metal ductwork is made out of gold there, so it's always a lot more expensive than other places. But I would say that's a good average across the country right now.
And I know ours came out a little lower because we did self-perform the ERV install, so we have a direct relationship with Zender that we've built over the years, so we were able to purchase that at a discount, and then we self-installed because of some of what we've talked about already. That's just the most effective way for us to do that. So
everyone loves talking about money. It's everybody's favorite subject.
Speaking of money, can you guys elaborate on your incentive program for your framers and the guys who are doing the air sealing work?
Yeah, I mean, it's pretty straightforward. There's each member of the team that's on that build after we're, before insulation and sheetrock. So we've got everything buttoned up, windows are in, mechanicals are in, nearly all, if not all, the penetrations are through the envelope. We do a third-party blower door with our rater, and if it hits a particular target, and we'll be ratcheting it down next year to even tighter, each member of the team gets a bonus. It's pretty exciting. They haven't missed it yet, which is really exciting, and it's such a fun day when it happens. I mean, we got people out in the field, people in the office, and we've got our own little chat spaces online that we're talking about that particular project, and everybody's kind of on pins and needles. Everybody wants to get it, everybody from the gal who's the bookkeeper to, the laborer on the framing team. So it's really exciting. It kind of aligns everybody's mind on what is most important. Yeah, I mean,
it's getting to the point we're going to have to live stream the blower door reading, because people are just popping off in the chat wanting to know. And I think what we use for so this is the blower door test prior to insulation and drywall. We might have some spray foam up if that's part of our air sealing strategy at the rims or in other areas. If that's going to be an impactful piece, that might be done. But, we're trying to hit passive house air tightness at that point. Assuming that we will pick up a little more air tightness through insulation and drywall, but their target is to hit passive air tightness before the house is even done. And they haven't, like David said, they haven't missed it yet. So
That's why we're gonna make it tighter.
Awesome. Great strategy. I find everyone gets excited when you break out the blower door and it's like teamwork. So you guys are creating a great culture down there. I mean, up there really, but.
We're right in the middle.
Yeah, perfect.
Middle coast.
Middle. And we have time for one more question. So everybody, please thank our speakers today, Joe, David, Miguel, and reach out to them offline if you didn't get a chance to ask your question. And we have one more, and it's the reason that I reached out to you initially, because it was about the makeup air. So Salvatore, would you like to unmute and ask your question?
Hey guys.
Hi.
Thanks for everything. Great chat. And I've always kind of meandered around this topic on makeup air. What was the exhaust capacity on the cooktop?
Trying to remember off the top of my head. You guys may know. I'm gonna look at the design, see if I can
Over
find-
400, obviously.
Yeah, I figured it was like 600-800 something.
Yeah.
It wasn't enormous. It
And
wasn't one of those giant things.
And that's what triggered, obviously, the installation of a makeup air system. Otherwise, if you were below 400, you wouldn't be installing one, I'd imagine, right?
And
Yeah,
you
I
used
mean-
the slim CASA unit, right?
What's that?
Did you guys use that slim CASA unit for that vent exhaust?
I don't remember actually.
I don't know that name, but it was a very, like, you could kind of see in the picture, it's
Yeah.
not.
Yeah, it's super slim.
Yeah.
Yeah, so the kind of the thinking around or behind range hoods generally is like, a lot of people may have had experience in a commercial kitchen with a really high powered hood, and they want that in their house because they cook a lot, and that's a totally reasonable thing to want, because the goal is to get those pollutants out of the kitchen as fast as possible, especially if you have a gas range or you do a lot of high temperature oil cooking. Very reasonable thing to want. What a lot of people don't know is that the shape and placement of the range hood itself actually matter a lot more than the fan speed. So if you can get it relatively low, of course you don't want to hit your head on it, but if you can get it deep and low and have a really nice sump shape, right? If you think about a sump pump, the range hood is a similar shape. That allows those pollutants to come off of the burners, right? They're, I don't know, roughly like a 45-degree plume in every direction around a burner, capturing as much of that as you can in the hood itself, and then allowing a smaller fan to remove it can obviate the need for makeup air. But sometimes, it really, I think it just depends on the project, and it depends on the criteria as to whether or not a larger fan is going to be needed for a range hood. You may find that you do need it, but and in any case, doing that sort of range hood is going to help a lot, no matter how powerful the fan is. Yeah.
So the pink elephant in the room is that the ERV is already penetrated through the building. So when we do hit the exhaust on it, we depressurize the unit. I know what the code says, but the reality is, in that intermittent use, is there a consensus that does it really matter? And do we really need, aside from the fact that we have a building code that enforces it, do we really need it? When we're on the
You say, do we
cusp.
really need a range hood? And
No,
could the
a
ERV just-
makeup air.
So if you go
makeup
over
air?
400 CFM and you don't, you
Let's say you had
won't get
500
you won't get
CFMs.
certification.
Hmm.
So there's
Yeah,
the simple answer.
The challenge is pressurization, right? So if you turn that system on, let's say you're all of a sudden exhausting 500 CFM pretty quickly, right? It is intermittent use, but it's intensive intermittent use, and usually it's happening at a pretty high. You have a high velocity fan in there moving a lot of air. You can, when your envelope is really tight, I mean, even a code level envelope can come under negative pressure,
Mhm.
and that you don't want that for a number of reasons. So when we're designing for neutral pressure, even with an ERV running, that's what we strive for. And so an ERV, unless it has boost capacity that can match the range hood's CFM capacity, you're going to be running into the same challenge, right? You're going to be under negative pressure, and you can cause a lot of issues with the system operation itself if the fans are coming under strain. But again, it's really like an envelope and durability and indoor air quality play to not come under negative pressure.
A typical air damper is what you guys are specifying. What we typically would find, but a kind of like a little foam gasket around it. And
yeah, the one we did for this, this is actually an area where I think the product market could expand a little bit. Like really well air sealed dampers, they're expensive, and they're not always easy to find at supply houses. And especially when you're getting motorized ones as well that are tied to a system like that. So they exist, and I encourage everybody to kind of map out what products are available to you. But we should be asking manufacturers too. If you're on the call, anybody who makes stuff like this, please make more. We need them.
Thank you.
Yeah, great question.
Well, I think that's going to wrap us up for today. We've really gone over time. I really appreciate you staying so long. Thanks for a great presentation. Friends, enjoy the December programming with the Accelerator. Register for Reimagine Buildings 24. And on behalf of the Construction Tech crew, we wish you a great end to 23. Thanks, everybody.
Thanks, guys.
Thank you.
Bye, guys. I appreciate it.
Great job.